Welcome! In previous videos you have seen what kind of operations we can perform on vectors. For example, we can add vectors by simply adding the components. We can also multiply a vector by a scalar by multiplying component-wise. A natural question is, can we also multiply two vectors? One idea would be the following. Just multiply them component-wise. Not a strange idea, right? But as it turns out, we do not use this operation. To understand why, let's go back to the first two operations. Consider the sum of two vectors. If you draw vectors as arrows, then the sum can be obtained geometrically by simply putting one after another. Note that we do not need the coordinate system. It is a purely geometric construction. Multiplying a vector by a scalar also has a geometric meaning. It is the same as multiplying the length of the arrow by that scalar. And again, we don't need the coordinate system to define this. Unfortunately, multiplying two vectors component-wise does not have any clear geometric meaning. So, the question is, can we find a product of vectors that is related to geometric properties of these vectors? And the answer is yes. Let me first just give you the definition. Take two vectors AB and CD. Then we define the product to be A times C plus B times D. So we multiply the first components of both vectors, multiply the second components, and then add these numbers. This operation is called the dot product of the vectors, and it is indicated with a dot. Let me show you an example. Consider the vectors 2, 3, and 5, minus 2. The dot product is the product of the first components, which is 10, plus the product of the second components, which is minus 6. So it equals 10 plus minus 6, which is 4. And note, the result is a scalar, not a vector. Okay, I promised you that the dot product is related to geometry. How does that work? As it turns out, the following is true. Consider two vectors v and w, and suppose the angle between them, as indicated in the picture, equals alpha. Then the dot product between v and w equals the norm of v times the norm of w times the cosine of alpha. Remember that the norm of a vector is the length of the arrow. I will not prove this formula here, but let's think about it for a moment. You see that the dot product can be expressed in terms of geometric properties of the vectors, their norms, and the angle between them. Let me give you an example of how this property can be used to easily find angles between vectors. Consider the vectors v1, 2 and w3, 1. To find the angle, we can use the relation we just saw. We can rewrite this formula as follows. The cosine of alpha equals the dot product of v and w divided by the norm of v times the norm of w. The dot product can be easily calculated. 1 times 3 plus 2 times 1 equals 5. We can also calculate the norms. The norm of v is square root of 5. The norm of w is square root of 10. Plug this into the formula, then we find that the cosine of alpha is equal to 5 divided by square root of 5 times square root of 10. This can be simplified to 1/2 times square root of 2. If you like, you can pause the video to check all these calculations for yourself. Now, what is alpha? Well, clearly alpha has to be between 0 and pi. And in that interval, there is exactly one value for which cosine of alpha is 1/2 times the square root of 2. Alpha equals pi over 4. You see that if you know the norms of two vectors and their dot product, then you can calculate the angle between them. But even on its own, the dot product provides information about the angle. Indeed, suppose the dot product is negative. The norms are larger than 0, so this means that the cosine of the angle must be negative. This means that the angle is larger than pi over 2. Such an angle is called obtuse. On the other hand, if the dot product is positive, the cosine of the angle is positive as well. Then the angle is less than pi over 2, and such an angle is called acute. And finally, if the dot product is 0, and the norms are non-zero, then the cosine of the angle is 0 as well. This means that the angle is precisely pi over 2. That is, alpha is a right angle. You see that the dot product is easy to calculate and it contains a lot of geometric information. In upcoming videos and exercises, you will see why the angle formula holds and what rules of calculation the dot product has. But first, it's time to practice.